See, yesterday you sent that photo, right?
Mm.
So,
Whatever that sir was, I mean, he confused me so much, so I stopped listening.
so we started by saying work done is F bar dot R bar.
Yes, sir.
I said I wrote it as R bar. If we take a small displacement, we can write it as F bar dot dr bar also.
But then we were going inside. I mean,
See,
yes,
here
sir.
you will get some dw, but we don't write it as dw. There is no such thing as dw. Work done is always work done. Will always be w. So let's say we can write it as w dash or something like that. But what I'm saying is simply we have written this. Can I write this like this in this form?
But then for the reference point, we took it from the starting, so
What
the
you're talking
displacement was negative.
what you're talking of is basically the position vector r bar.
Yes, sir.
So I am just saying that suppose I take a block from here to here r bar, or I take a block from here to here and say dr bar, eventually I will get some work done for that, some work done for this. Can I write the mathematical equation like this? I'm
Yes,
not
sir.
saying these two are equal. Saying when we write work is force into displacement, if it's the infinite small displacement, I'll use the second equation. If it's a significant change, I'll use the first equation. That's the difference.
Yes, sir.
So I can write it like this. Then we wrote work done is negative of change in potential energy.
Yes, sir.
And if F bar is parallel to dr bar, I can write this as FDR.
Yes, sir.
Now from these two, I can write F is equal to minus du by dr.
Yes, sir.
Okay.
Yes, sir.
So why I wrote the first equation was because we used it like that. It's not wrong. Okay. We used it from there. So from the reference from where we have used it, I wanted to start. Okay.
Sir, yes, sir. And why did he use
I
a
will
concept?
first I'll first remove this.
Okay, sir.
Basically, instead of starting from there, if we start from here, because there is nothing wrong with writing it as dr bar. For small displacements dr bar, the work done can be written as f bar or dr bar.
Yes, sir.
Now, if you look at this entire story, we haven't mentioned any property or anything about anything. There is force, there is displacement. That's all that we mentioned.
Hmm.
And we wrote this.
Yes, sir.
And another thing is work done is equal to minus of du. I mean, work done can have many other change in energies also, right?
Yes, sir.
So the work done due to this force, we are writing it in terms of change in potential energy. So my point is, can I treat this as a general equation? Okay, I
Yes, sir.
I can use it as a general equation. So when you're solving a question, because these things might be you might be feeling new and stuff. So you can take that 95% of the places you can use this. Only 5 or 10% places. That means when you're reading a question, maybe in exam or maybe while practice, if you have to know, can I apply this or not? So maximum probabilities you can apply. If you feel that there is something involved with this, then that means maximum probabilities you can apply. So with practice only you can figure out when you can apply this and when you cannot apply this. Most questions, 95% of the questions, if you are coming here, if that fellow will say an aeroplane is moving with 300 miles per hour and it is traveling for 10 hours, find the displacement. You will not come here. No?
Mm.
There's something force and something potential energy should be written over there for you to think of this in the first place.
Yes, sir.
And if you're thinking of this in that particular question, that means there is some relation. Then what you have to think is 95% of the time it is applied. So confidently apply it. So where it is not applied, you will get to know while practice. There is no such generalized situation where I can say it is not applied. The only conceptual way I can say it is not applied is if suppose work done is not just change in potential energy, it's also kinetic energy, it's also some heat energy, nuclear energy. Work done can be any change in energy, right?
Yes, sir.
But if you're coming to this equation after reading a particular question, 95% chance is there that so don't forget the minus sign. You will not forget the minus sign because now you can write this by yourself only, right?
Mm.
Work done is equal to FDR is equal to FDR is equal to minus DU is equal to therefore F is equal to minus DU by DR. If he gives a U as a function of R, you will just simply differentiate with respect to R and get force.
Yes, sir.
Okay.
Yes, sir.
Now one more point I want to add, then I will come to your doubts. Somehow you will see everywhere, I mean, in any other physics lectures and also in YouTube lectures of many people, there is a word used conservative force, conservative force.
Yes, sir.
But as you know, I'm very bad at English. So I don't mention conservative force anywhere because what is the definition of conservative force?
I don't know properly, sir. Some work done will be done. The
Work
work
done
done is
is
equals path is zero. I don't know, sir. I don't know properly.
work done is independent of the path followed.
Yes, sir.
So best example is suppose I am in a building. So let us say this is first floor, second floor, third floor. From here, if I walk all the way towards left side, then jump over here and walk all the way towards right side, then I'll reach here.
Yes, sir.
Or I directly jump from here to here.
Yes, sir.
The change in potential energy will be mgh only, right?
Mm.
And initial velocity is also zero, final velocity is also zero.
Yes, sir.
I was standing here, I went and stood there. Kinetic energies are initial and final are zero. Only change in energy that has happened overall from initial to final is change in potential energy.
Yes, sir.
So if I walk all the way through like this, or if I directly jump like that, either which way, my total work done will be mgh.
Yes, sir.
And it is independent of the path followed.
Yes, sir.
Or if I walk all the way like this and come up, or if I walk all the way up and then come here and eventually land myself here. Again, I am giving kinetic energies are all zero, initial and final. Now, Chi, what is the work done? 2 mgh, right?
Yes, sir.
If the first one is mgh, we can take it as 2 mgh. Now, if you left and upwards or upwards and left, both paths, my work done is 2 mgh.
Yes, sir.
Write it down. Conservative forces conservative forces are conservative forces are forces due to which forces due to which work done work done is independent of path followed. Work done is independent of path followed.
Yes, sir.
So there are situations where work done is independent of path followed. There are situations where work done is not independent of path followed. For example, if I'm running race, so if I take a shortcut and come to the final point, or if I am running all the way through the track, the loss of energy in my body when I run all the way through the track is more.
Mm.
If I take a shortcut, loss of energy is less.
Yes, sir.
So my body there is not doing any conservative force.
Yes, sir.
Okay, so the force where the work is conserved actually. Okay, but again, if I say conservative force is the force where work done is conserved, it's like Ramu is named because he is Ramu. So that's why I gave the definition in a different way. Work done is conserved means conserved word anyways you know. Momentum conservation, energy conservation, right? So work
Yes.
is conserved. So I go straight and left or left and up. Work is conserved. Work done by whom? Work done by the gravitational force
Yes, sir.
is conserved. Purposefully, I made initial and final velocity 0 so that kinetic energy story doesn't mess up with us.
Mm.
Okay. Take this down and then you were asking some doubts. So once you take this down, then ask. Or you can ask me while taking it down also. But have both of it in your class notes. And here you write it as this example we are wrote for conservative force. Also, I mean, I said I don't use the word conservative force because of my English, but sorry, I forgot to tell. There is no necessity for us to label in a particular way. Rather, it's like Karela. I eat Karela and I know Karela. Rather than I label Karela and then Karela. What is Karela? I don't know until unless I eat it properly. So there
Yes,
is
sir.
gravitational force, there is electrostatic force, there is magnetic force, then nuclear forces, and we keep on doing all these forces. And wherever situation you see that work done is independent of path followed, you can say it's a conservative force by yourself, right? Then you know it automatically. That's why I don't mention conservative force anywhere during my lectures. Already student is confused, you confuse them even more.
Yes, yes.
Yeah, tell me. You were asking something.
They're over here, then they used F conservative dot PR.
I didn't mention anything. No? I don't know that much of physics, right? If I know that much of physics, I'll be teaching to some hi-fi, PhD students. I didn't mention anything, right? Who said conservative, non-conservative? I don't know. If you know, you tell me.
I don't know, sir.
That's it. Leave it. Who cares? Don't think of. Only thing is, remember that example for conservative forces. And you can write the statement as conservative forces and work done is independent of path followed. By experience, you will eventually figure out where, in which situations, the work is independent of path followed and all. So, overall point is don't take conservative force, that words, so seriously. Nothing to do. I didn't mention anything over here, right?
Yes, sir.
We just wrote it step by step, and we got f is equal to minus du by dr. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.